Good afternoon, everyone, and a very warm welcome. We'll wait for a minute or so and we'll start the session. So let's start the webinar for today. Uh, Good afternoon again, everyone, and a very warm welcome. My name is Saurin, and I'm a data and AI engineer at Royal Cyber. Before we dive in, let's do a quick tech check to make sure everything is working smoothly on your side. If you can see the main title slide on your and on your side, and also you can hear my voice clearly, please type a quick yes or give a thumbs up in the chat. Excellent. Thank you. It looks like we are good to go. Also, as we move through the presentation, please feel free to drop any questions you have into the chat at any time. We have a dedicated Q&A session at the end, and we'll be keeping an eye on them. Let's talk about our speakers for today. First, I would like to introduce my colleague Heather Jan, our principal data engineer for AI solution. Heather leads many of our most complex AI implementations, and he'll be diving into the technical architecture with us later. Next is me, Saurin Patel. I'm an data and AI engineer at Royal Cyber. I'm thrilled to be guiding you through today's topic on building and scaling enterprise AI with Databricks. And we are honored to join by Fan Hu, a solutions architect at Databricks. Fan, would you like to give a brief intro about you?
Yeah, hi everyone. My name is Fan Hu. I'm a solution architect from Databricks. So I've worked in data and AI domain for 10 years now. I'm excited to join today's webinar as a guest speaker to introduce more about the Gen AI and agent solutions in Databricks.
Thank you so much, Fan. It's great to have you both over here. And let's talk about the Royal Cyber. Just to ground today's discussion in a bit of credibility as a quick snapshot of Royal Cyber. We have been in this game for over 20 years. That means we have seen every wave from from on-prem BI to today's Gen AI, and more importantly, we have learned to productionize each one. We are a global team of more than 2,000 specialists, including over 500 certified consultants across key platforms like Databricks, AWS, Azure, Snowflake, SAP, and Salesforce. The breadth is our strength, and it lets us build and stitch solutions end to end instead of just handing you a pile of siloed tools. Our 10 plus offices on 5 continents allow us to run true follow the sun model, and a shoe raised in Chicago at 5 p.m. is already been worked on in India or Melbourne by 8 p.m. We have delivered this value for over 600 plus clients in retail, banking, telecoms, and pharma, all of whom have pushed us to optimize for both cost and performance. And because we have partnered with all major players, AWS, Microsoft, Databricks, SAP, and Snowflake, it means whatever your stack is, we have already vetted and integrated it. The the net takeaway is we bring global scale, deep certification, and battle tested playbooks to every management and engagement. Now, let's look what we'll be covering today. Our game plan for today is we'll start with AI agent revolution and why this is the pivotal moment. We'll then explore why enterprises absolutely need multi-agent systems. After that, Fan will be leading the Databricks control plane with Agent Bricks for building agents and MLflow for governance. Then we'll look under the hood with an architecture deep dive. And once you see the blueprint, Heather will bring it to life with our Claims Copilot demo. and we'll wrap up showing you the how we can get you started and followed by a live Q&A. So the big question over here is why are we talking about multi-agent AI now? Because the first wave of generative AI was about chatbots and single task models. The next revolution, the one happening right now, is about specialized autonomous agents that can collaborate. And this isn't just a theory, it's a clear market trend. Gartner projects that by 2026, 40% of enterprise AI will rely on multi agent orchestration for compliance and decision making. As the quote on the slide says, enterprises are no longer asking if AI can help, but how to trust it at scale. The trust is the key. A single general purpose agent can't just be enough. To build enterprise grade AI, you need multi-agent system that brings domain specialization, coordination and tool use, governance and explainability, and continuous improvement via MLflow. But the need for this goes even deeper. It's about solving a fundamental problem of control. Before multi-agent systems, the enterprise AI landscape was often chaotic. We had fragmented AI tools leading to inconsistent logic, significant data risk, and absolutely no audit trail. And this is what we call AI chaos. And it's a massive source of cost and compliance gaps. But with a governed multi-agent system built on Databricks, the picture changes completely. By combining Agentbricks with Unity Catalog and MLflow, we move to a state of control. Your AI becomes secure with data and tool access strictly controlled by Unity Catalog, consistent because you have defined consistent decision logic across all agents, and transparency. With every action evaluated and monitored by MLflow, you are moving from chaos to governed control. To show you what this governed platform actually looks like from the Databricks perspective, I would like to hand it over to Fan to explain the Databricks ecosystem in a more better way. Fan, over to you.
Yeah, all right. Thanks, Soren. So this diagram on this page shows Databricks Gen AI ecosystem. We have a lot of tools here that serves different purposes. So first, on the data side, we have Unity Catalog. So this is basically Databricks central data management and governance solution, which helps you centrally manage the access control of your data and models. So when we build Gen AI applications, right, we want to make sure it has governance. Users can only query the information that they are allowed to access. So Unity Catalog is our data governance solution here. And for the large language models, so Databricks has partnership with almost all the main large language model providers, including OpenAI, Anthropic, and Google AI, right? Which means through Databricks platform, you can basically access all the latest and greatest large language models from all these main providers. And in addition to this, we also have a lot of built-in tools that makes it really easy for you to build the production level Gen AI applications, including multi-agent tools, um, as well as tools like MLflow for you to track the model performance and evaluate your models, which we're going to talk more in the following page. Can we go to the next slide? Cool. So one of the main tools within Databricks Gen AI landscape is Agentbricks. So this is the no-code solution within Databricks platform that makes it really easy for general users to quickly build an agent application without the need of writing any code. So it supports a lot of common Gen AI applications, including tasks like information extraction, which allows you to quickly extract key information and insights from your unstructured data, like PDF files or image files, and turn them into structured output. As well as some other applications like Knowledge Assistant or AI Genie, which allows you to quickly build an interactive chatbot application that can be used to answer questions based on the information on your structured data and also unstructured data. And on top of these single agent applications, in Agentbricks, you can also quickly build a multi-agent supervisor application, which will provide you with a supervisor agent that can coordinate and orchestrate multiple single agents. So if you have use cases where you need to, search for information from both your structured and unstructured data, you can build a multi-agent applications to achieve this goal. And alternatively, you can also call some user-defined functions registered in Unity Catalog from Agentbricks. So this will allow you to add some custom logic and functions to your agent application. Next slide, please. So why are we choosing Databricks to build our Gen AI agent application? First, Agentbricks allows us to quickly prototype and build the common Gen AI applications from single agents, from single agent to the multi-agent applications. And then secondly, MLflow 3.0 provides the end-to-end real-time traceability of your agent applications. So it tracks every steps, including the user's input, the agent output, as well as the intermediate decisions in between. So that providing deep visibilities for debugging and performance optimization. And it also provides monitoring and evaluation for your Gen AI applications. And on the deployment side, for all the Gen AI applications that you build in Agentbricks, we will provide you with an API endpoint, which you can easily integrate with your other applications. And on the government side, like I mentioned earlier, you can use Unity Catalog to centrally manage the access control for your data and models. So in summary, Databricks make it really easy for you to quickly build Gen AI agent applications and also help you to deploy your application into production environments, which comes with traceability and governance. Next slide, please. All right, so next, let's talk through a real-world Gen AI use case, right? So this is a use case in the insurance industry, and we have a few cartoons here. So the first cartoon here shows a frustrated customer who is calling an insurance agent to inquire about her bill, which she thought would be covered by the insurance. And to address this customer's question, the insurance agent has to manually search through multiple disconnected source systems, which is very time consuming and also frustrating as well. And at the same time, in the second cartoon, it shows a billing coordinator at the hospital. So she received a denied claim, but the reason code is very vague, and she has to search in like a 200-page policy document to figure out the cause of the denial. So our goal here is to basically have both parties to figure out why was the claim denied and how do we appeal. Next slide. In order to automate the manual policy document search task, we would like to build an agent application called Claims Clarity Copilot, right? So the goal here is basically help us to get an instant, clear breakdown of the bill with the exact policy clause cited. Yeah, let's go to the next slide. So this is the perfect use case to leverage the multi-agent supervisor tool in Agentbricks to build this Claims Clarity Copilot application. So on the left-hand side, we have listed a few key challenges that we have discussed so far, including like manual policy lookup, disconnected systems, a lack of audit trails, etc. And on the right side, we have our solutions. So we can solve all the challenge by building a multi-agent orchestration tool in Agentbricks. And these multi-agent tools will call two different specialized agents. So one is an AI BI Genie agent. So this is basically the built-in chatbot tool in Databricks, which helps us to gain quick insights on our structured data, like billing data, payment data, etc. And the other is a knowledge assistant agent, which is a document Q&A agent built on our unstructured data, like the policy documents. So the multi-agent orchestration tool can help us retrieve relevant information and combine the insights from both our structured data and unstructured data to help users form a complete answer. And on top of that, MLflow 3.0 governs the entire process. So it tracks all the user inputs, the agent output, ensure all the answers that we got from the agent is auditable and explainable. Next slide, please. Cool. So with this Copilot tool, yeah, we can reduce the manual information search tasks from hours to seconds. And why are we able to achieve this? This is because first, we leverage these specialized agent tools in Databricks to handle the query for different types of data, right? So for the structured data stored in tables, we can leverage AI Genie, which converts users' question in natural language to SQL commands and retrieve the answers for us. And for the unstructured data like PDF documents, we can leverage Knowledge Assistant Agent, which can help us to build a RAG application to search information from the documents. And multi-agent supervisor tool is what combines the two agents together. And on top of that, the Agent Bricks also has seamless integration with the rest of Databricks platform. So both the structured data and unstructured data will be managed and governed by the Unity catalog to make sure we follow the right access control. Next slide, please. Cool. So Agent Bricks helps us to quickly build the multi-agent applications that can help us search answers across our structured and unstructured data. And MLflow 3.0 is our trust layer here that makes application enterprise ready. So it allows us to track performance and cost, monitor some key agent metrics. It also helps us to automatically evaluate the quality of the answers provided by the agent applications. And it can also track and manage the versions of our agent applications so that we can compare the performance and pick the version with the best performance. And with that, I will hand over to Hydra now to talk more about the actual solution architecture of the use case and also do a demo on this use case.
Thanks, Van. Okay, let me share my screen real quick. Share my screen. All right. Right, share. I hope this is the right screen that's getting shared. And so I hope we're able to see a flow diagram.
Yeah.
Awesome. Okay, so what Fan actually talked about was the Agent Bricks platform, and obviously how we can use MLflow 3.0 to as an evaluation harness to capture the discrepancies in our agentic solution that we've developed, right? Now, this of course has a lot of elements to it. There's the user feedback that obviously we want. We also want our experts to uh, score the responses of the models, and we also want to combine these results from both these sources and actually have an evaluation loop through which we can constantly improve our agentic or our AI agents prompt models, or let's say fine tune them to better respond according to what's optimal. So this diagram shows that feedback loop in other words. Uh, you can see that the feedback that we receive from our end users actually goes through a loop, goes through a pathway where we actually get all their traces. These traces can be identified through the trace UI, from which you can build an evaluation data set, and then you can have your experts have a labeling session where they can actually go through each evaluation data point, or let's say each trace, and see whether the model performed accordingly or not. Then you compare your results to what should be, or the benchmark results, and you see whether the quality has been improved or not. If no, you iterate on you iterate on your app, track changes with prompt registry, where you can actually track your prompts and have your lineage stored there. Obviously, if your quality has improved, you deploy those changes into your latest version and have the end user use that. Aside from having a human in the loop, which I just described, which is the users as well as the people, or the subject matter experts, SMEs, that are going to evaluate our models, we also have LLM judges, something that is very native to MLflow 3.0. We can actually use LLM judges to evaluate or or score our AI agents according to some guidelines that we've provided. So the LLM judges, so the MLflow framework actually comes out of the box with some out of the box LLM judges, like completeness or relevancy. All of these are metrics that can score your model for relevancy or completeness or accuracy, and we can have our own custom scorers score our model as well. But this in a nutshell gives you the whole evaluation framework, how it's going to be in a loop fashion. I'll go to the next slide. All right, this is a very clear depiction of what we used to get to the solution of our problem. Obviously, like Fang mentioned, in the insurance space, both providers and insurance agents, they both deal with a flood of highly repetitive and data-heavy questions, right? Both from the provider side as well as from the end user side, which are the policyholders. Now, things like what part of this claim was denied, we need to carefully extract that. This is some sensitive information, right? Um, Obviously, that needs some planning, and that you can see in the architecture what we've planned. So on the left side, on the left hand side, there's the icon legend to actually help you decode what icon describes what. But here on the left, we have our organization data. This can be data from this can be the data coming from CRMs, or insurance companies, ERPs or CRMs, or any SaaS platform, right? And we ingest that data using lake flows, declarative pipelines, or this is the process we did to get our data into a lakehouse. Now, this data obviously is very raw and lacks context and is not AI ready. Obviously, the solution for us is to have a medallion structure through which we can give some structure, or at least some AI readiness to the data, so that it can be easily consumed by our AI agents. So as you see that the AI readiness increases from left to right. And then on the right, we have Mosaic AI's module, which is handling all of the agentic orchestration, or which is processing all the uh, information, or which is processing all the information for RAG, right? So all of this data is being fed to these agents, which are in Mosaic AI's agent bricks, that are being served via endpoints, right? We have got, as we know, we've got the AI gateway, like Fan talked about, on which we can serve our model endpoints that we've deployed. Now, this data from the lakehouse was structured, and you can have unstructured data in lakehouse as well, but obviously in the form of tables. But this data actually caters to the structured data that's coming from CRMs. On the other hand, we have some policy information documents. These can be PDFs, text documents, markdowns, files from Google Drive or OneDrive, SharePoint, etc. All of these can holds information with regards to policy, and that is being fed to the assistant. This is the knowledge assistant. So the knowledge assistant has access to the insurance policy documents, whereas the Genie, which is the Databricks SQL assistant, has the structured data Q&A. It does RAG on structured data, right? So the whole agentic framework lies within Mosaic AI. Obviously, then you've got agent evaluation. Obviously, so when you get your models ready, they have to go through an evaluation loop. They have to act accordingly to certain guardrails in order for them to, or in order for this agent to be deployed to production. Okay. Inside MLflow 3.0, you can see that we've got scorers, judges. We give its we use some evaluation data to test our agentic solution. Also, we collect all the feedback and make sure that that feedback is recorded and stored in tables for tracking and setting up further guidelines to improve our agent's quality. The architecture then guides us to Unity Catalog. So this is where we're storing. This is where all the governance comes in. Obviously, the system prompts and feature tables that were being used for evaluation are being tracked by Unity Catalog. After evaluating our agents, we make sure that our system prompt can be fine-tuned, or and save those results in the form of tables inside the lakehouse. And then the feedback loop takes us back to the Mosaic AI agents, where you can incorporate those and those fine-tuned prompts into our Genie or your knowledge assistant, so that your agent's quality can improve. This was the overall solution architecture. Now, let me stop sharing my screen and go back to showing you the demo. Now I'll have to stop sharing, or actually share the other screen. Give me a second. Share. All right. Kindly give me a second while I pull a few things up. All right. So what you see over here is the Databricks pane. It's what you see when you actually go to Databricks. Of course, now I've opened up the Agents tab, but obviously when you go to Databricks, you might be redirected to the workspace. Now in our workspace, we've got some documents or some notebooks or some experiments that we've performed. But obviously this session is about AgentBricks. So let's go to the Agents tab real quick. You can see it located under the AIML header. So let's go to Agents. And you can see that it's still in the beta version. It's not currently in general availability, but even though it's in beta, it's extremely powerful. Now I can only imagine what it'll have when it's in general availability. When you go to the Agents pane, you can see different. You can see different modules here. You can see the information extraction. You can see knowledge assistant, AI/BI Genie, the multi-agent supervisor, custom LLM, or code your own agent. These are different ways to set up your agentic solution, right? You can have an agent extract structured data from some PDF or some Markdown or some TXT file. At the same time, knowledge assistant, you can you can set up a knowledge assistant by clicking build and build it up from scratch, giving it PDFs and system prompts. You can set up a Genie space that we've set up and have it manipulate structured data. And this is what we're going to present, and it's the multi-agent supervisor that we've built. It's called multiple agents that are being orchestrated or controlled by a supervisor. On the other hand, you can deploy your custom LLM to perform custom text tasks, and then you can code your own agent. Obviously, you have to go to the docs and import the relevant SDKs to do that. It's going to be Mosaic AI framework. Let me actually go to the multi-agent supervisor that we've built, sorry. Now, as soon as you open it, you are redirected, or you're directed towards the configure tab. this is where you can set up your multiple agents. This is where you have to give some system prompts to your agents, as well as name your agents, create more agents, or let's say you can see over here some functions like explain claim denial. This is a UC function that we've added, which is a capability of the current ecosystem of multi-agent. You can also have genie spaces added to it. So let me show you the genie space. Agent claims is the genie space we've added as an agent into this multi-agent configuration, and we've given it a system prompt, right? So the system prompt says that you've got this data source. You have to talk in a very professional tone. You will have these tables through which you'll get answers to certain questions. All of it is in the system prompt, and obviously it has been fine-tuned by through the usage of MLflow 3.0, like I said. At the same time, you've got the knowledge assistant endpoint. Now, this knowledge assistant is the policy and coverage intelligence agent, right? It's the agent that the supervisor goes to when the supervisor wants information about a certain policy, right? Let's say I have a gold HMO plan, and I want to know about the attribute or the, let's say, the attributes, or you can say the details of the plan. When I give the system that prompt, the multi-agent supervisor will automatically direct me towards this knowledge assistant. Let me actually prompt it in front of you so that you can see how powerful it is. My first prompt would be more towards the knowledge assistant. So we'll start off basic. And my question would be, is the knee replacement surgery covered under the silver PPO plan? Now, this might be a common question that an insurance agent might face. Instead of them going through some documents to get to this information, all they can do is just paste the same question with this AI endpoint and query that agent to get to the answer. So the multi-agent starts querying, it cleans out the query and hands off to the knowledge assistant. Now the knowledge assistant is working through the documents to get the answer. And we get our answer pretty fast, right? As we get our answer from the knowledge assistant, the system hands the answer to the multi-agent, and the multi-agent is, here you go, this is the answer. Also gives us the relevant footnotes on where it received all its information from, which you can trace back. But this is good. This is really easy for the insurance agent to just type in a quick query and get to the answer. Another question that I would ask is, let's say, compare the gold HMO plan to the silver, right? And so it does the same process all over again. It calls the knowledge assistant, and the knowledge assistant starts getting us the information that we need, the policy aspects, and the relevant details are then filtered out by the multi-agent supervisor. Now let me try to ask it a more challenging question, and this time over from the structured data side, right? From the claims domain. It's the kind of an inquiry an agent or a provider might raise. They might raise it internally, right? So the question is, let me just copy paste it. So the question is, Emerson had a claim received on this date, and she says that she's on a gold HMO plan and was cared for by Dr. Alex Adams. Can you tell me the details of what was billed and how much was paid by her? Give a detailed report. Let's see what it does, because the data has to be pulled from a table now, right? And the table is, like I said, it's constantly getting updated. So what happens is the multi-agent starts uh, to clarify the question first, and then it's going to parse it and forward it to one of the agents, which we have to see. So it says handed off to agent claims. The agent claims is basically a Genie space. It got us the exact row of that incident. And now it's saying, I found the claim details. Here's the comprehensive billing breakdown for her claim. This is the claim ID, the service date, and the billing breakdown, right? Insurance insurance allowed this much, your plan paid this much, which where a negative indicates a reversal for adjustment. So actually we paid more. Important notes and recommendations. This is very neat, since the AI agent isn't only retrieving us the information, but it's also giving it a story. It's presenting the information as a story, which is more digestible by the end audience, in this case, the provider. All right, let me ask it another question. The question is, my name is Dr. Mason. I need all the imaging MRI services, which I have performed, that were denied, right? So a provider comes in and they're saying, I have performed these services, but my claims were denied. I need to get paid for this, right? They call the insurance agent, and the insurance agent is like, wait, let me go to the database and actually look at or retrieve that information. So, like I said, this was pretty quick. After asking the question, the multi-agent forwarded that question to agent claims again, because it knew they might have the perfect answer for it. The Genie space then gave us all the incidents where the MRI claims were denied for Dr. Mason. And from this structured data, the multi-agent parsed all the information and filtered out the perfect story for us on why it was denied and what are the resolution steps for having these claims sorted out and billed to Dr. Mason's name. So these were just some samples to show you the power of the multi-agent orchestration inside the agent bricks, which I have to say it again is in beta version. But yet you can see it's so powerful even right now. But I just showed you the front end part where I've set up these agents, and you can see that they are performing really good. But how did they perform so good? What measures did I take to make them perform so well? So there's an improve quality tab that is right adjacent to the configure tab. And over here, you can see that I've given it some few shot examples, which are generalized. And through these few shots and the guidelines, this agent actually knows it has some guardrails. It has a specified path of reasoning and retrieving answers or structuring those answers so that all of these guidelines, according to these few shots, are met. You can add more few shots. You can have these few shots exported as a table and store them in a lake house, so that you can actually see how well they're perform how so that you can see for lineage purposes whether we had to change a question and the guideline to make the agent perform any better or not, and what did we have to change. That's, of course, about the lakehouse and the uh, the Unity catalog feature. This is one way to improve quality. Another ways to improve quality is actually through experimentation. So what I've done over here is have a notebook. Through this notebook, what happens is I actually make this endpoint, this multi-agent orchestration endpoint active, and give it some inputs. Like by inputs, I mean some questions or queries. Now, these are some eight to 10 queries that I ask from the agent, and I tell it, okay, what you have to judge on is the professionalism. You have to judge on completeness, and you have to also judge based upon retrieval relevance and relevance to query, right? Also safety. So here are some guidelines that I've, or the LLM judges or scorers that I've initialized over here. I start the run and I see that I've got over 9 pages of runs, which let's go to the main evaluation or experimentation, a slide to show you that. This is not a slide actually, this is the real experiment that I performed. So we see that completeness, relevance, safety, and guidelines are all the, uh, as well as the state, request time, execution time, they're all the metrics that I'm tracking right now. Now, let's see, we see over here that the first query failed for completeness. You can actually hover over it to see why it failed for completeness, or you can click over here on the query and you'll be seeing a tab opened where you can see the details and timeline, the linked prompts, the outputs that were given, and if it wasn't complete, why wasn't it complete? So it'll give the rationale for that. This is a really powerful feature of MLflow. This is called the LLM judges. They not only rate your answer, but also gives you a rationale for why your answer wasn't at par with the metric that you specified. Another way to actually make your agents perform better is obviously through feedback, uh, by through human in the loop, like I showed you in the flow diagram in the slides. You can actually create a human in the loop session by going to uh, labeling and create a labeling session over here. Over right here, I've created a labeling session myself. You can create another session by clicking on plus. Let's say I name the session my session 2, and I create this session. So after creating this session, obviously, you have to give it some data so that the labeler or the subject matter expert can go through those questions to see the answers. How do I do that? Well, you go to traces. By going to traces, you click on some questions that you want your SME to label or judge the answer of, and then you select your questions and you add it to the labeling session. Once you add them, you go back to your labeling page, and there you go. In the second session, you have these 3 questions which need to be vetted out. And that is very simple to do. You just share this link with your SME, which is again your subject matter expert, and they guide you towards this. This link guides you towards a page where the billing session has begun, a labeling session has begun, right? So you've got the question and you've got the answer. Now it's on you. What were your expectations and what is the feedback that you need to give, right? Any feedback, all right? You go through each question, and once you're done giving your feedback, that feedback is automatically stored through MLflow uh, alongside your traces. Another thing is the evaluations, right? So like I said, I performed an evaluation on my agent, but now I want to compare how better my agent has become. You can do that by comparing your evaluations. So I created an evaluation about 40 minutes ago, and I want to compare it with the one I had about 3 weeks ago, right? I do that. So I select my current evaluation and select my latter evaluation. And basically, if you want to compare evaluations, you have to have the same questions go into that agent, right? So I see that in some questions, my response actually decreased in quality. But in some questions or queries, my response increased in quality. Similarly, if you scroll down, you can see a response that failed to be professional has actually become professional because I set up some guidelines, etc., etc. If you hover over them, if you hover over why they failed, you can actually get to know why they failed and then provided a guideline in the improve quality tab to improve the answer for this question. Uh, so these are the ways, like I said, both through human in the loop as well as through LLM scorers, you can actually improve your your AI agent's endpoint and have it perform optimally. If it isn't performing optimally, you can incrementally increase the quality of it through that workflow. All right, and with that, uh, we go back to our slides. Let me stop sharing my screen and give me a second while I share it again. Great. So this is where we stopped, and I'd like to pick up from here. So now that we understand the architecture, now that we understand how MLflow works and how you can improve the quality of your agent and make it enterprise ready in an evaluation loop, let's go towards what we've learned. In the summary tab, we see that what we learned was obviously is that Databricks is a unified centralized data platform through which you can do a lot of governance processes, as well as it's the platform that is currently uh, uh, you know embedded with the capability of creating highly powerful AI agents uh, with MLflow, through which you can provide a governed AI lifecycle. We've got the multi-agent systems uh, that are capable of solving complex business problems. We learned that, right? That they are essential for bridging the gap between structured data and unstructured policy. And through these data, it is able to be decisive and provide the end user with a response that actually drives decisions. Also, uh, not to forget to mention that Royal Cyber is your strategic partner to scale securely. We've worked on a plethora of AI agent solutions that we've developed for a slew of clients in this past year, and obviously uh, from a couple of years actually. But that's going to be all that we learn about this seminar in this webinar. Please let me know if you've got any questions. Soren, if you'd like to read the
Sure.
questions from the questions tab.
Yes, we have a couple of questions here. So the first one is, what kind of data readiness or architecture is needed before implementing agent breaks? I think Fan can answer this one
Okay.
better.
Yeah. So for the agents that like the knowledge assistant agents, right? Like doing the document Q&A on your unstructured data, like all you need to do honestly is just basically provide your unstructured the PDF file, right? Like store that in unique catalog and provide the location of your files. You don't need to do any additional like processing on your unstructured data, like some document chunking, embeddings. All that is basically taken care of by agent bricks, right? And then for your the AI BI Genie, which is run on your structured data, right? Of course, we will expect, for those like table data, right? So we'll expect, you provide some data with, with some good data quality, right? So you will have like some basic data quality controls before that. So the better quality of data you provided, and the better performance you will get from those uh, queries on your structured data. Yeah. So hope that answer your question.
Sure. That's a great explanation. And also the other one is how does Databricks ensure governance and auditability across all the multiple AI agents in a supervisor agent? So in this, if we talk about governance in Databricks, it's not an add-on, it's a backbone for Agentbricks because everything is being backed by Unity Catalog, and Unity Catalog is governed till the back, like also the model endpoints, also the tables, also the schemas, everything is being governed by it. So that is all Agentbricks is built upon. And it inherits the governance from MLflow 3.0. So every agent is being tracked, its latency, cost, accuracy, inputs, and outputs. So these two are the main backbone of it and can help you cover the audits, logs, lineage, and all the feedbacks if you want in agent breaks.
So I see another question, and it's like it says if multiple Genie spaces were added to multi-agent system with similar tables and somewhat conflicting metrics, how to avoid hallucination between Genie spaces? Right. This is a very valid question, but I would say if you have multiple Genie spaces with similar tables and somewhat I mean if they've got similar tables, I do not get why we're having multiple Genie spaces then. Uh, we have to be very discerning the about what agent solves what because each agent has to be specialized, right? We can't have multiple Genie spaces having the same tables, right? uh, I don't see a very effective strategy that you can apply, any strategy you can apply in order to avoid hallucination between the Genie spaces, because essentially all of them have the same tables, right? Uh, Again, in the multi-agent orchestrator, there's the AI that is deciding on what agent to choose, and the AI agent is basically looking through what agent is doing what, correct? So if both of your Genie spaces or if you have three Genie spaces that does the same thing and you've given it the same system prompts, I don't see how you can avoid hallucination. And then we've got another question. It says, could you plain explain what is agent and multiple agents? Soren or Fan, if you want to
Sure.
take that up.
So we are using multiple agents because there are multiple tasks to be done in that. So each agent is being specialized in one part, solving one part in its own, and they can collaborate in a way that can get answers from multiple agents and get us a specified answers on it by querying. Like they can work in a team, orchestrate better, and get us a perfect output we needed. Also, there is one more, like how many specialized agents can a supervisor agent can manage effectively within agent bricks, and what determines their scalability? So yeah, in this we have the capability of adding 20 agents along with the tools in agent bricks that can orchestrate way better together as per their specialized capabilities of each agent, and they can solve a problem and orchestrate very well into it.
Do we have any more questions?
I think that's all the questions we had.
Let's wait for a bit to see if we get any more questions. So one question that was posted just before you were about to sign out was, how do I know whether my Databricks have Mosaic AI or not? Fan, perhaps, would you like to answer this?
Yeah, so the admin should basically on the top right, like you should basically see like a preview options. So like the admin basically can enable all this the new features, right, that is currently in public preview or beta to the end users. So you can basically go to that like a preview page and then search for Mosaic AI. You should be able to see Agent Bricks there. Yeah.
Awesome. Awesome. Also have one last question. It says, what factors could help improve the performance of multi-agent supervisor? Mine could figure out which underlying genie to go to quickly. However, it takes much longer to get the answer than asking the genie directly. Right. Well, I would just say, and maybe Soren and Fan could add to my answer. The multi-agent supervisor, if you look at it, it's still in beta version, right? So we have to give it some time so that it is able to do everything efficiently. But uh, more importantly, it's orchestrating, or let's say it's orchestrating the flow of answers, right? So the orchestrator first decides what genie to go to, and then they hand off to that genie. The query passes to the genie. The genie answers the query. The answer passes back to the supervisor. The supervisor makes sense of the answer and then pastes a refined version of that answer. Right? That makes more sense. All of these handoffs obviously do contribute to taking time, which is why Genie is able to answer things faster than the orchestrator, because the orchestrator has to also vet the answer that was uh, provided by the Genie. Um, so that is my take on it.
Correct. Also, it
Correct,
has to go through different agents if they are able to solve that query or not. So
correct,
that
correct.
takes a bit of more time.
But you can actually optimize the speed by providing it guidelines, like I did in the improve quality tab, which is right next to the configure tab. The more guidelines and few shots you have to give it, the better uh, it has the idea on how to answer to some specific usually asked questions, and the faster it becomes. I've So one last question before we sign out. It's how the supervisor redirect the task to the agents, how it decides this. Now, Soren or Fan, if you're interested in answering this.
Sure. So we have like dedicated, the multi-agent supervisor has dedicated uh, kind of information about all the agents, and it decomposes the query in a way that it gets to know which agent would be successfully solving this query in a better way, and it will be orchestrating in that manner to that agents having those capabilities that could solve the query. So that helps in a better way to orchestrate only those agents that could solve that query.
Yeah, and also when we set up the multi-agent supervisor, right, when we include certain specific agents, it will ask to like provide the descriptions of like the agent we include, right? So we also want to like better guide the multi-supervisor agent by providing some accurate descriptions on those agents that you provided, right? So for example, you include this like Genie space A, you expect this Genie space will help you to answer like a billing related questions, right? So you providing those information in that descriptions when you include the agent that can help uh, better guide the multi-agent, to know for a certain specific task, right? Which agent should we go to search the answer?
Amazing. Awesome answer. All right. Thank you, everybody. Let me go through a few points before we sign out. Here are some of the offerings that are aligned with Royal Cyber. So not do only do we actually give you a solution, but we are actually our advisory and strategic can become strategic partners in your AI transformation journey as well. We help with implementation and integration, training and enablement, and managed services. And now we go towards the key takeaways. You can read them out real quick. I'll give you 5 seconds, but this is essentially what we've covered in the summary. And a final note on saying thanks. Thank you everybody for joining this session. We are very glad that you will be obliged if you could join our upcoming sessions on Databricks as well. Hopefully, we'll be partnering up again with Fan, and the topics which we'll be covering next would be obviously more about AI and data engineering, especially going towards agentic AI. But the features that Agentbricks is rolling up are with a very high pace. So you will see a lot of changes in the Agentbricks ecosystem the next time we sign in. Thank you so much, everybody. Thanks, Fan. Thanks. My special thanks to Fan and Soren and everybody who joined this seminar. Thank you so much.
Thank you so
Thank
much,
you,
everyone.
everyone. Bye.
Thank you.